Hello. So let's go over linked list, which is probably one of the most important concepts that we've learned so far because it kind of brings together everything we know about vectors, pointers, data structures, and even some algorithms stuff. So for those of you who don't know, I'm going to briefly go over what a linked list is. So far in this course, we have covered vectors and we've covered arrays. A linked list is very similar to a vector, which is very similar to an array. So basically, just to jog your memory, a vector is simply an array that we have the ability to resize and change. And we have learned how to make our own dynamic arrays by using pointers. So linked lists kind of bring all of these concepts together. So we'll use pointers and data and make pointers and data behave like an array. And that's essentially what a linked list is. So what an array is a solid kind of contiguous block of memory, meaning that everything is together, where you have data which you can read. So for example, if I have an array that had the number 0 and 0, 1, 2, I could go to this index and then read the array, and then go here and read it, and then go here and read it, and then here I could read it, right? And I would be able to advance to the next element of the array just by doing. So for example, if like, let's say this array was called ARR, all I have to do to change which element I'm looking for is to access the indices that each array is. So position 1, 2, and 3. So for example, if I wanted to do AR2, it would read number 1. So so that's essentially what an array is, and a linked list is actually very similar. However, the main difference between a linked list is that in the array, all of these elements are right next to each other. But with the linked list is that the elements are scattered in memory. So like the linked list, because we're using dynamic memory, because we used a new keyword with the linked list, so they will live in our dynamic memory, all right? And so this is where pointers come into play, and we have to be careful with managing and deleting pointers and doing all the stuff that we know. So what a linked list is a linked list is just an array that has been scattered in dynamic memory. So for example, you have a 9, a 0, a 1, and a 2. So basically the numbers in your the numbers in your array are the same numbers in your linked list. However, they've been scattered. And we know, and we can tell the program that, hey, this 9 comes before the 0, and this 0 comes before the 1, and the 1 comes before the 2. So when we read our linked list, when we do like when we read each of the elements of the linked list, it will still print out the same thing as the array. So like these two are equal, but the internal structure of the data is different. So this is essentially what a linked list is. You just have your data, and then you have something that is gonna link it, link to the next element. And the way that we link things is we use pointers. So a linked list is essentially broken up into 2 bits. I should probably use white. You have the element, and then you have the pointer. And this pointer points to next element. So So you can kind of visualize it like this. You have the data, and then you have the P, and this P just points to the next piece of data, and then the P, and that just points to the next piece, and so on. So a little bit of terminology. The first element of the linked list is known as the head. The last element of the linked list is known as the tail, which is pretty self-explanatory. And then we know something is the tail when there is nothing else that it points to, or it points to null, meaning it doesn't point to anything. So when we reach an element of the linked list where the next pointer points to null, we have hit the tail, and this is the end of their linked list. And the head is the element that has nothing pointing to it. So there's nothing coming in. And we have to keep a track of the head because it is really hard for us to check if anything's pointing to a pointer. We are only able to tell what the pointer is pointing to. So we have to manually interface with our linked list only using the head. So in our main program, we'll be often keeping a track of the head because we can't really tell what's pointing to our pointer or what's pointing to our linked list. So we have to keep a track of the head. So how do we make a linked list? Well, we can use, so remember how I said a linked list has to have two parts, the element, which is the data, and then the pointer that points to the next element. So we can use a class or we can use a struct. And I'm just going to go back to VS Code so I can show you. So we can make a struct and we can call it node. Um, and the node has, let's do int data, and then let's make it a pointer to another node, and then we'll call that node next. And then I have to do a semicolon here. Cool. So this data is what's going to be our element. Oops, I didn't mean to do that. And then this node pointer next will be the pointer to the next element in the linked list. And yeah, that's basically it. That's basically all that we need to make the actual elements. And the tricky part is to actually make them link together. So we're going to make an element called add to head. So how we want it to be is we want so first we want to make the tail node. So let's do node pointer, let's make it a equal to null ptr. So basically we have made yeah, so we now made a null pointer and now we're gonna add something. So actually first I'll just make an add to head function. So the first this is the thing that's going to be at the very end of our linked list, so at the very end of the tail. And now I'm gonna add one element to my linked list, which will be our head. So I'm gonna do node star, which means pointer, add to head, and all it's gonna take in it's gonna take in another node, and I'm gonna call that previous. So all we do is we return. Oh, and also we need to take in the data. So let's do int d and then node head. So what we're gonna do is we're gonna return a new node, and we're going to do D for data, and then we're going to pass in the previous. So what this is going to do is, so when you do add to head, we want to input what we want our data to be. So for example, if we did like 9, we could put in the number 9, and then what's going to do is uh, it it is going to link our new element into what was passed previously, which will be this node object, which points to nothing. And then it's also going to return a node pointer, so we can add other things into it. So we could do A. So our head, actually, I'll just call it head, so it's easier. So now I'm going to make our head equal to add to head, and I'm gonna input, let's say I want to make 2, and then we're gonna add in the previous head. So I'm gonna take a photo of this so we can go through it and actually help you guys to actually understand what's actually going on here. Okay, so we have our struct, and it's called node, and it takes in 2 parameters. It has 2 properties. It has a data integer property, and it has a pointer that's next. So just like this. So this is our data property, and this is our pointer, which we call next. Okay, and yeah, that's it. So here is where it gets a little bit tricky. This part right here. So first we are going to declare a node, a pointer, and it's going to be called head. So this means it's a pointer. Okay, and uh, and it is a pointer for our node struct. Okay, and its head, and this head is gonna point to nothing. So essentially, we're making a pointer which points to nothing. So essentially, this is what we're making. We are making this part right here. We're making a pointer that points to nothing. Null. Okay. Cool. So you see how we're starting to make the tail. So now what we're going to do is we're going to keep a track of the head, because remember how I said we have to keep a track of the head because we can't really tell what the head, if there's anything pointing to the head, we can only go this way, but we can't really see what's pointing into it. So we have to manually keep a track of the first element. So this is our head. But like in a linked list of size 1, the tail and the head are the same thing, right? And that does make sense. So for example, if we didn't have this, and we didn't have this, and we're making a linked list, well then what would the head be? Well, the head would obviously have to be the same thing as the tail. So that's essentially what we're doing right now. So I made a head function, and it's called add to head, and it takes in 2 parameters. So it takes in a data, and it takes in a node pointer, which is everything here. So it takes in data, and it takes in a node pointer. And the thing is, like, we don't really care about doing the node pointer, because the node pointer will always be taken care of for us, meaning that because we have this null pointer already made, we already have a pointer, so the only thing we need to add is the data. So that's why here the only thing that you need to worry about as a programmer is only the data, because the previous pointer has already been taken care of because we already make it. And it kind of becomes a chain reaction, meaning that we don't really need to worry about this previous pointer because we're always going to be passing it in. Like this, we will always pass it in. So for example, our pointer will always naturally point to this because of how we have this function set up. And what I mean by that is because we're taking the previous node, we are always gonna we are always gonna add it into the head. So this previous node becomes, so this previous node is what our head is. So for example, we have a head right here and it's the null pointer, right? And here we're going to do add to head. So do you remember how in C++ or most programming languages, all of this code gets run first and then this gets run? So even though these two things are the same thing, they this head is actually referring to that head over there. So what we're doing is we're essentially doing this. We're going to do add to head, and we're going to pass in a 2, and then we're going to pass in a node pointer, which is called head, and then this pointer is pointing to nothing. So that's essentially what's happening here. I know it can be a bit confusing to wrap your head around this, but try to understand it and practice, and hopefully it kind of starts to make sense. It's a kind of like recursion. It's kind of hard to understand recursion until you like manage to think through it. So anyways, so that's our previous pointer. And then we just input our data, and then we have to return a new struct node because we're adding in a new element. And we are going to return the pointer to that node. So for example, now when we return the pointer, what we're essentially doing is this pointer is pointing to nothing, and where we are going to return a path for our new pointer to come into. So that's essentially what's happening here. And if we were to add in one more element, so we want to keep a track of the head, so that's why I call it head. And I'm doing add to head, and I'm going to add in a 0. Okay, so I'm just going to take a photo of this, and we'll go back here. Okay, so here we are calling the same function again, which is add to head, and it is taking in the current head, which is a pointer, right? So for example, this is what's really happening. This is what the pointer is pointing to, right? So we are returning, so we are giving our function the ability to have it point to it, right? And now we're adding in a new element because we're going to return a new node. And then we're going to add in the data, which is 0. And then the pointer is going to point to it. So this is essentially how our linked list is being made. So this node star essentially is returning like a memory address to basically let us point to it. Like it's kind of like saying, hey, I have been made, and if people want to find me, you can find me at this memory address. And then we're passing it in here. So this is the memory address of the previous node. And we're passing it in, and we're setting the data, and we're letting our node link to the previous memory address. So this is how we're essentially building up that links list. I hope that kind of made sense. I know it's not the best explanation in the world, but I'm kind of trying to do my best. I do know it's a complicated topic. Okay, so far our linked list has two elements, 0 and 2. So why don't we start building up the rest? So I want to add in a, let's just add in a 1 and a 9. So also, you know how we're starting it from the backwards? So we're kind of starting from the tail, and then we're adding in this, and then we're adding in that, then we're adding in that. So that's what I'm going to do, and then I'm going to show you how to print the linked list. So all you do is you just copy and paste a function again, and it's just going to do the same thing that I've been telling you guys. So, and then we add in a 9. Cool. Okay, so this is going backwards, and now let's do a print function. So our print function doesn't have to return anything. Let's do print. And then all we need to take is our node P. Cool. Or let's just make it N. Cool. Okay, so basically what we're going to do is essentially, because we're returning from the head, we are starting from the beginning. So all that we have to do is and we have to make sure that we want to make sure we keep on doing this until we enter, until we hit our null pointer. So while n, so what this means is like while n is not a null pointer, well, n is not a null pointer. So essentially, while n points to something, we're just going to do std count and data. Oh, I have to dereference it. Does that work? In data count node add. You're not really sure why that's not working. Okay, let me think. Oh, I have to do I have to dereference. No? Okay. And then let's print off something with just an arrow. And then we're gonna do std code std window. Okay, and that should work. So all you have to do now is I have to do print, oops, and it should print out everything so far in the order of 9, 1. It should print out something like this. And then it'll probably print out null. And then Okay, that's what it should print out. Let's see. Ah, oh, I forgot to advance um my code. Okay, let's get this to quit. What's Command C? Control C? Okay. So oh, so what we do is we do n equals n dot next. So now we're telling it to point to the next element. So this should work. Cool. And I have spaces. Let's try it one more time. Cool. So 9102. Yeah, exactly how I wanted it to go. So yeah, that's kind of how it works. And yeah, remember how we have to advance it to the next element. You could also do this in a for loop. Um, so for example, yeah, so if you want to do this in a for loop, it would be something here I'll just copy this. If you want to do this in a for loop, it would be something like this. For node n, actually, yeah, I don't think we need anything here. Just one second. Okay, so for node n, we could do as while n. So while n is equal to something, we can do n equal n dot next. Not really sure if that would work. We'll do the same thing again. Okay. Okay, I think this should work in the for loop method. Yeah, okay. It is a bit more complicated, but I prefer the while. I think it just makes more intuitive sense to me. Cool. Okay, yeah, so we've covered add to head and how to print a linked list. Let's try to do add to tail. So now let's try to add in an element at the end. So this is our tail element, and what we want to do is now we want to add in one more element that goes to the very end. So for example, 8. So that's what we want to do now. So because we're only keeping a track of the head, what we have to do is we have to go through the entire linked list until we reach the point where we know that the next element is going to be equal to null. And then when the next element is equal to null, that's when we're going to modify what this is pointing to and make this point to a new element, and then make that element point to the null. So we inject it just like that. Okay, let's do our add to tail. So we do have to return our node, and let's do add to tail. And we're going to do the same thing, same method signature. So because we're going to preserve the head, what we want to do is we want to back up what our head is, so we can always return the head. Also, if you really wanted to, you don't really have to return anything because you aren't going to modify the head, but it is good practice too. So let's make a backup. So let's do node pointer head equal prev. Okay, so and then what we're going to do is we're going to return the head. Okay, so this is just to back up the head. And then we always want to return the head so we can print up the entire linked list, right? Cool. So now what we want to do is we want to go through our linked list until we get to something that points to null. Okay, so let's do while we named it prev. So while prev is pointing to something, we're gonna do star prev. I'm sure there's a better way to do this. I can can I just do this? Well, yeah, actually, yeah, this is how you do it. So yes, so while prev, we're gonna make prev equal to next. While let's do while p dot next. Yeah, so for example, while p dot next is pointing to something, we are gonna make prev equal to prev dot next. So here we are going to advance to the last element, which is 2, and we're gonna say, hey, what's the next element you're pointing to? Is it pointing to something? Then we're going to keep on advancing, and if it's not pointing to something, we're going to stop. So this will bring us to element number 2, which is the end of our list. And here is where we want to inject the new element. So we're going to do prev dot next is equal to a new node. And remember, it has to be a pointer. Or actually, we can just do add to head. We could just call that add to head function and then pass in. So which number do we want it to do? Which number to say? Is it 8? Cool. So 8, and it points to nothing. Cool. And I think this should be it. This should be it, or what we need to do add to tail to. So let me do head equal add to. Oh, oops, I hard coded it. Add to tail. Let's do 8, and let's do head. And then we can print off the head again. And this one should do 8. Okay. Moment of truth. Both of them pointed to null. Okay, let's see what happened here. Okay. While prev Okay. Wait, what happened to my... Wait, why did this get destroyed? Like, oh, I removed the print. Okay. I think it's, was it like that? Ah, no. Okay. think, I think that should work. Cool. Yeah. Okay. So I just destroyed my print function. But yeah, so now we've learned how to add it to the tail. And I'll try to go over what I did, so it kind of makes sense. I'm also kind of learning along with you guys, so I'm I may not be the best teacher, but I'm doing my best. Okay. Well, just like how I forgot this thing and the error function thingy. Okay. Anyways, so also the arrow function, for those of you who don't know, the arrow function, all that it does is it just puts the ampersand, I'm sorry, the star and the dot into one thing. So what it does is it will take this, which is a pointer, it will dereference it. So we can actually like read what it's pointing to, and then and then it will read the data, which is there, which is another pointer. So that's all that the arrow function does. If you wanted to, what you could do is you could do star prev, which will dereference, and then afterwards I could do next, and that would do the exact same thing as prev arrow. I know it's a bit confusing because we're also printing out arrows, but if this makes more sense to you, go for it. But if this makes sense to you, this is a bit better because it's less typing. So yeah, but if this is confusing, you can just use this, and actually let me just double check that's actually it, and I'm not just like spewing random stuff. Yeah, okay. Okay. Um so let's do our add to tail. So what we're doing is here is we are backing up the head, because remember how we're always going to return the head. So our linked list is currently so what's our linked list currently? It is 9102. So this is essentially what our linked list. Oh, I wasn't even oops, I forgot to share. Okay, so what I went over was I just went over the arrow function and how the arrow function is the same thing as the star and the period, which is the same thing as this. So like these two are equal to each other, and you can use whatever you want. Um, and yeah, this is what our linked list looks like right now. Okay, so first we're gonna back up the head. So we're gonna back this up. because remember how we always want to return the head, so we can return it. And then what we're going to do is with this function is we're going to advance through everything until we hit until this is not true anymore. And remember that a null pointer is equal to is basically will give us a 0, so this will terminate it. So we're going to keep on advancing until we're at the bottom thing. So we're going to be like, hey, is this pointing to something that's not null? Yes. Is this pointing to something that's not null? Um, is this pointing to something that's not null? Yes. Is this pointing to something that's not null? Yes. Is this pointing to something that's not null? Yes. Is this pointing to something that's not null? False. So now our next uh, so this is our next now. So our next is currently equal to nothing. Or our previous, I mean, our previous is currently equal to nothing. And we're gonna, okay, so now because our previous is equal to nothing, which is null, we are gonna inject a brand new node and we're gonna add it in. And it's gonna have the data that we want, which is the 8, and it's gonna have a pointer that points to nothing. And then we're gonna lastly return the head. So when we print it again, it is gonna go through and beautifully this will get printed. So we get 9, 1, 0, 2, and 8. And yeah, that's basically how we add to tail. Also, everything I've shown can also be done recursively, but I'm not really good at recursion, and I find that it makes less intuitive sense when you do it with recursion. It's also harder to teach, but recursion is a little bit more elegant and it's shorter, which if you want like elegant and short code, go for recursion. But if you find it too confusing, there's nothing wrong with these types of solutions, these types of iterative solutions, because I find that they're more logical. Okay, let's do our last topic, where we're going to reverse the linked list, which is a thing I'm actually the least comfortable with. So you might see me struggle. But essentially what we're going to do is yeah, I'm still showing this. So currently our linked list is, actually, why don't we make a new one? Oops. Why don't we make a new linked list? Let's just keep it simple. So let's make our linked list 1, 2, 3. And we'll like link it like that. And to reverse the linked list, what we're gonna, and this is equal to null. So to reverse, and this is the head. And this is the tail. So when we want to reverse a linked list, what we want to do is we want to do this. We want to make this point to this and this point to this, and this now points to null, and this becomes the tail, and this becomes the head. So this will print, and this will print. Okay, so that's the difference. We're essentially reversing it. And yeah, like I said, bear with me, because this make it bumpy. Okay, so to reverse the linked list. Actually, why don't I just code it up on paper first? And I can walk you through my thinking. So to reverse the linked list, let's start with our method signature. So we have to return a pointer. And let's just name this reverse. And all we're going to do is we're just going to take in a pointer. and we're gonna call that pointer, or I mean our node, we're just gonna call that n. Okay, because essentially we don't really need anything else. That's all we need. So we need to keep a track of certain things. So let's make some variables. Um, okay, so we have to keep a track of let me just think this through here. So we have to keep a track of our I think we have to keep a track of our previous, current, and our next. We have to keep a track of P, which is previous, our current, and then our next. And that's how we're gonna do the switcheroo. Okay. So let's make this all like pointers. Node, previous, current. Oh, I have to do star. Next. Let's just make this to equal to n. So our previous and our current, our next are all equal to the same thing. Okay. So we're gonna leave our previous the way that it is. Let me see. Let me think. Also, we do want some logic to where if the linked list is size 1, then we just return like nothing. So what if I did like current equal prev dot next? So what this would do is this would make it like that. And then we can use a while loop. So while current is actually pointing to something. Okay, let me think here. So what we want to do, is we want to make previous point to null. And then we want to make our current point to the previous. So we get that. Oh wait, okay, yeah. So this is where our next comes in because we have to back up what this is. So we want to do next equal to current dot next. Cool. So this way we're jumping it, and then So our previous on next is equal to null pointer. Our next is equal to current on next. And then our current next is equal to previous. Okay. Cool. And now we're just gonna do some updating. So we're gonna make our previous equal to current, and then our current equal to next. And then that should keep moving everything over. So this will then happen. But then this will then point to a null pointer. Okay, we have to fix that. I mean, the logic for everything else seems okay. And then it's just as a previous, we're gonna lose that one null pointer. Isn't there, can't I maintain a backup somehow? Actually, why don't I just like walk through what my code is doing? Okay. So currently I'm doing 1, 2, 3. Okay, and then I make everything equal to my head. Okay, so my prev, current, and my next. And what I'm gonna do is I'm gonna make current equal to this one. And while current is not null, okay, that's good. I'm gonna do, okay, I'm gonna make this is not equal to null. Okay. And then I'm gonna make next equal to current.next, which is this. And then I'm gonna make current.next point to my previous. Okay. And then I'm gonna make my previous equal to current. And then my current equal to my next. And this is gonna happen again. And my previous or next is going to go to null pointer. And then my next is gonna move here. And then my current or next is gonna be equal to previous. And then, okay. So I have to do something to make sure that it gets preserved. Well, maybe I just like need to do this thing once. Yeah, what if I move this outside of my while loop? Uh, okay, so this way, okay, so this way, moving forward again. Um, oh my God, I have to go through the whole stack again. Okay, let me try it. Also, this is how I recommend coding. I mean, like if it helps, like just try to think it out first and then solve it. And this is basically what I do whenever I'm doing the homework. Okay, so make everything equal to this. Okay, current equal previous dot next. Okay, and then I make previous equal to null. Okay, and then while current is true, I make current equal dot next. Okay, and then I make the current point to that. Okay, and then I make my previous equal to my current and my current equal to my next. Okay. Okay, so now I'm here and I make my next equal to whatever current's pointing to, and then I make my current dot next point to my previous. Okay, and then I make my previous my current, then my current my next, and then it'll be null. Okay, cool. And then all I have to return is I have to, so this is my head. So I think I just return previous. Yeah, I think that should be a, okay, let's try that out and see if it works. Oh my God, I can't type anymore because I was writing for so long. So let's let's start let's make a few variables, call them node previous, um current. Can I even like multi-line assign like this? I don't even know, bro. Is this even legal? Yeah, it is. Okay, cool. Okay, current equal previous dot next. Okay, and then previous dot next equal null pointer, since we only need to do this once. And then while current is pointing to something, we're going to do next is equal to current dot next, and then current dot next is equal to our previous. And then we're going to have to update our variables. So our previous equal now equal to current. Now our current is equal to the next. And then we're going to return previous. Okay. Let's see if this actually works. Okay. Okay. Ah. Okay, I got it. Okay, that doesn't work. Why? Okay, I think it might just be this multi-line thing. So, K82019. Yeah, cool. That's it. Cool. Yeah, I think that's about it. So we went over what linked lists are, how to add to the head of the linked list, how to add to the tail of the linked list, how to reverse a linked list. The only thing I didn't cover is how to add in order. Adding in order is kind of done in the same way where we add to tail, but the only condition is like rather than terminating once you get to the null, you like terminate you terminate when you know that the next element is actually like less than the current element. So that's when you would add it in order. And I will leave that up to you because I don't want to, yeah, because this video is already 1 hour long. Yeah, cool. Okay, all right. Best of luck. Bye bye.